Namaste, welcome to Sthitapragna channel. Previous video or previous episode, we have seen how to install and set up Spark. So right now, you should have already have some type of Spark setup, whether it is Ubuntu or Windows, doesn't matter. You should have a Spark and a Jupyter up and running. Got it? And I have one question. Did you guys ever waited hours for a Spark job only for it to crash near the end? Maybe if you are already using it at your work. If you are not, then that's fine. But most of us who are using it might have faced this scenario. Today, I will show you the fastest way to avoid that pain by using the PySpark shell and the SparkSession builder correctly, right from a Python REPL. What is an REPL? We'll talk about it in a minute. You will learn how to launch PySpark, which we have seen in previous videos, but we will see that again. And we'll also create a Spark session manually, which we have done when we install it on Windows and through Jupyter. And then we'll understand what the startup messages mean. Then we will explore Spark's directory layout, and we will tame the noisy logs with the right log level. If you have seen the logs that were displayed when I ran PySpark in Windows, there are a lot. Now we will see how to not have all those log messages displayed there. So let's get you productive, shall we? And that too very fast. So why a REPL for Spark? Python has a REPL for interactive development, and PySpark being a Python library, it plugs right into that. You have already seen this, just so you know. Interactive execution gives you instant feedback, super helpful because Spark operations can take time. Rather than compiling or submitting big monolithic jobs, we will iterate quickly, test in small steps, and reduce the chance of long running failures. Got it? Why do we use REPL? Because of the interactive development it gives or comes with REPL, which gives us faster feedback. You don't have to wait an hour to see the result. And it is safe for experimentation on data intensive jobs. Every data frame you create, every filter you add, you will test on the REPL. It will give you output, and then you will be like, oh, this is what I expect. Then you will continue your coding. This works locally as well as in the cloud. Assuming you already have a working Spark installation. If not, if you are facing errors, issues during Spark installations, I told you to let me know in the comments. Then we can arrange a Zoom meeting according to my availability, and we can fix that. But going forward from this lecture onwards, I will assume that you have a working Spark installation locally or in the cloud. Let's confirm everything is wired up by launching the PySpark shell. How do we do that? We will open our terminal and we will run PySpark. Here's exactly what you might see when you run PySpark. If whether you are using Windows or Linux, it doesn't matter. If you followed the setup video, our episode 1, then you can just go to Anaconda prompt in Windows. I'm telling you because I'm doing it on Linux. Go to Anaconda prompt, then switch to your environment, which was Spark env that we created, and then type PySpark, or you can just open Jupyter notebook from there, and then Jupyter will be open, or you can just open PySpark and then your REPL will be open just like this. So I will go to terminal. Imagine this is your Anaconda prompt. Okay, let me increase the font a little bit. I don't know if you guys can see it or not. Okay. So let's assume that this is your Anaconda. And by the way, even here I can create the environment, but I'm not going to do that because we did a different Linux setup, right? So I will stick with that. Then just type PySpark in your, okay, PySpark. What happened? Did- We set it up here, right? This is weird. Oh, never mind. Never mind. Never mind. The reason we are seeing this is because we need to run that notebook. Now it will set up all of them, but let's see how it works because we pointed our REPL to trigger Jupyter. So it won't open the REPL now. It will hit the Jupyter directly. We won't see all the log messages here like we would do if you just run a REPL. So since we are talking about a REPL, let's go there and open the REPL. How are you going to do that? Okay, we can do that. It's not a biggie. Close it. So let's see where we are. We are here. So let's go to Spark. Okay, so all you need to do is bin PySpark. So this will open your REPL and you can do that in Windows as well, which will open it. Okay, so this is what it should look like. Now, when you are using Spark or PySpark locally, you most often won't have a full Hadoop cluster pre-configured. For learning purposes, this is perfectly fine, so don't worry about it. And this one shows you we are using Spark version 3.5.6. And here, if you see all these messages, um, you can see the default log level to 1, correct? The Spark is indicating the level of details it will provide to you. We will see how to configure this in this video in in the coming sections. And if you look at here, Spark UI is available. You can see that here at this address. We'll check about this much later. I cannot click on it. That's fine. Okay, let's copy this. I won't go much into. Oh no, that's fine. What is it? 10.0215. Oh, is it 4041? Yeah. So this is the Spark UI. I won't go much into it here now. We will look at that in some other chapter. But you can open it. This is the URL that will take you to the Spark UI. And the PySpark shell, it provides an entry point for you through the variables Spark and SA. You can see them. Remember, in Jupyter, we had to create our Spark context, but in REPL, it creates it automatically for you and makes it available through these two variables. And you see this one, these arrows, right, which means that your REPL is now ready for your input. And remember, PySpark is using the Python available in our path. This will display right here. You can see that Python version on the master node. Since we are working locally, this is the Python installed on our machine, or at least on my machine. If you followed me, you should see something similar as well. So that's about the REPL. When you are learning, right, I highly recommend IPython for interactive PySpark. Why? Because it has better pasting behavior, syntax highlighting, and history. If you're wondering how to get that, let's go here. I didn't show you the IPython. Maybe I should have showed you. But let's do this. Okay, we are in Kunda, right? Anyways, let's create um, another environment here and let's name it PySpark. Oops. I will show you. I mean, as I mentioned, I want to show you each and everything that's out there. I will show you IPython and what is the difference between that and the REPL in a minute. And IPython is kind of similar to Jupyter. Let's see that in action actually. Python, what do we have? 3.13, right? And let's have pandas in this. And IPython and PySpark. What was the Spark version we had? That is Spark. I'm assuming both would be the same. So let's try 3.5.6. Let's click enter. Okay, so it's not available. How about 0? Okay, that's not available as well. Okay, what about that? Okay, that's not available as well. All right, it worked for 3.5.4, and it's saying is not installable because it requires which conflicts with any installable versions previously reported. Okay, so okay, it should be less than 3.10, which can be installed. Okay, that's fine. Let's go ahead and 10. Okay, that's fine. Let's install it. Okay, so now let's go to Conda activate and we'll say PySpark. And we are in the PySpark. You can see that from the fact here. And we activated it. Now let's run IPython. And we are in IPython. So here, as you can see, you don't see any of that SCR Spark variable being created. Imagine this as your Jupyter, right? If I had to create the Spark context, then I have to follow similar to what I did in Jupyter. Okay. Dot SQL import Spark session, enter, and Spark equals to, remember this, Spark session dot builder dot get or create. Now it creates. Now you will see all these messages because it created it now. It created the Spark context right now. So that's how it works. You can type, I mean, if you type SC, it will think it as a, but we created it as what? Spark, right? Now you can use it like we previously used, like spark.read, etc. You can perform those operations, right? So this is kind of similar to Jupyter Notebook, but you are doing it from the REPL. I hope you understood the difference between that and this. And we already set up Jupyter, so we don't have to do it right now, but let me can Control D will exit from this, and I'm fine with that. Let's exit from it, and we are in PySpark. It doesn't matter. If you want, you can switch it back to Conda activate base. Sorry. Okay, now you know the difference. Let's go back to our I cannot execute PySpark here, but let me execute it from here. Now you see the difference. Now it will execute, it will create my Spark context again. That you can see here. Right? Same idea. Spark gives you SC, Spark and web UI address. If you are on a cloud notebook environment like Databricks, you will usually start in a notebook by default. That we will check in another video in this particular chapter. If you, let's say, launched PySpark like this, but you want to switch to another REPL, you can type exit or Control D. I was doing Control D so far. You can also do exit. It will work. PySpark is convenient, but in many editors and IDEs, you will start a regular Python or IPython shell, and you have to create the Spark session manually. This applies to glue jobs as well. You have to create your own Spark session there. It won't come by default. It won't create it for you by default like REPL. REPL is the only one that will create a Spark session for you. This is also how you will wire Spark into existing Python tooling. Let's do that now, shall we? We will import Spark session. Then we will use the builder pattern to set an app name. And then we will materialize the session with get or create. This pattern scales later when we add configs for clusters, dependencies, and more. Again, you can write whatever I'm going to show in Jupyter or in IPython. So let's go ahead and do it in Jupyter. So how do I do that? We'll say Spark Notebook. Then it will open my Jupyter. Look, new Python 3. Okay, here we are. Now, this, as I mentioned, remember, even in IPython, you will have some brackets and colon. Is just that is from command line or terminal. This is from browser. That's the only difference. So we are going to type PySpark. You need to get used to it. So I would recommend you to type it SparkSession, and then we will create Spark. You can put the brackets or you can leave it. It's up to you. Okay. Here we'll give our app name and that will be our app name. That's it. What is this telling you? The from PySpark SQL import session, this the Spark session entry point, which is located. Where is it located? It is located in the PySpark.sql package, providing the functionality for data transformation. Right? This pulls in the main entry point for the SQL data from API. And then you have PySpark, which provides a builder pattern abstraction for constructing a Spark session where we can chain the methods to configure the entry point. You can put more dots and add more properties. And providing a relevant app name helps in identifying which programs run on your Spark cluster. That we'll check later on when it comes to that. And here we set a descriptive application name. This shows up in the Spark UI and logs, which is invaluable when you are monitoring multiple jobs. By using the get or create method, your program will work in both interactive and batch mode by avoiding the creation of a new Spark session if one already exists. Note that if a session already exists, you wouldn't be able to change certain configuration settings, mostly related to JVM options. So if you need to change the configuration of your Spark session, kill everything and start from scratch to avoid any confusion. Okay. In practice, if you need to change JVM level options or fundamental Spark configurations, stop your session and restart the REPL or your script to apply them cleanly. Remember that. Historically, PySpark centered around Spark context, which is the RDD first, and modern PySpark uses Spark session, the data frame first, which wraps a Spark context, but it adds SQL or data frame features. You understand the difference between old and new, right? Now, let's run this one, and you can see using an existing Spark session only will take effect. Now, since we created that, let's access that. And if I run this, this is similar to running SC before. It should show my Spark context like local PySpark shell. And app name, it is showing me PySpark shell, but it is supposed to show me whatever app name I have put here, but it looks like it didn't take that. If one already exists, that's fine. Let's stop the previous session, then let's create the new session. I guess that will solve our issue. That's okay. Now you can see instead of the PySpark shell, I guess when it started the PySpark shell, it created a session. I'm assuming that's why it showed us that. If I check the JVM, it would have shown the same thing again. But now you can see it is showing our app name here. So I just stopped the session that existed before and I created it. Okay, so now let's go to our terminal again and let's open a new tab. And here make sure you are in the Hadoop directory, right? So let's not like this. Let's do it like this. And these are all the files that we have in the Spark directory, Spark home directory. We'll go through and learn about them right now. So the readme.md file that you are seeing here, it it contains detailed instructions how to use Spark shells, build from source, run examples, find docs and configs, and even how to contribute. And then the bin, which is the important one, all the executables you will see like Spark SQL, PySpark, Spark Shell, Spark R, and later Spark Submit for standalone apps. And then you have sbin. This is admin scripts for starting and stopping Spark components across different deploy modes. And then you have Kubernetes. Since Spark 2.4, it includes Docker files and instructions to build Spark distributions and images for Kubernetes. And the data sample text files for MLlib, structured streaming, and graphics. And finally, examples. This is example code in Java, Python, R, and Scala, great for learning and quick tests. We will use some of them during Scala lectures. These directories evolve across Spark 2.x and 3.x, but this layout gives you a mental map of where things live. And by default, PySpark shell runs at var. We have seen that, didn't we? Which can still feel chatty while you are learning. Non-interactive scripts default to info, which is even chattier, right? You know the Java log levels, right? You have the trace at the highest, which means maximum number of messages. Then debug, then info, then warn, then error and fatal, I guess. So the lower you are, the less number of messages you will get. The higher you are, the more messages you will get. So by default, we have seen when you run PySpark in REPL, you got warn. Okay. You can change this per session with just one line. Okay. Per session, you can change this. How do you do that? You will use something called Spark contest set log level. So let's assume let's go here. So we already have our Spark contest. So let's run it like this so that we will have SC and we can use SC. Set log level, and then you have to mention your keyword, and that keyword will be one of whatever I mentioned. If you turn it off, no logging it up, and of course that is not recommended. You can have fatal, error, warn, and info. That's it. You won't have debug and trace here for at least the Spark. Now, as I said, we already have warn, which adds warnings. If it is fatal, only fatal errors will be shown. And if you change this to error, you will have fatal plus other recoverable errors. And if you put info, it will show you runtime info like repartitioning and recovery details. Remember, when using the PySpark shell, anything chattier than one might appear while you are typing, making the shell hard to use. Feel free to experiment, but in this tutorial, we will only show output when it's useful. And yes, setting the log level to all is a great way to prank coworkers who didn't log their screens. You didn't hear that from me. Okay. In practice, I use error when I want peace and info when I am diagnosing behavior. For day-to-day learning in the shell, warn is a solid default. Got it? So let's recap what we learned here. You launched the PySpark shell, understood the startup output, explored Spark and SC, created a Spark session manually using the builder pattern, learned how to navigate the Spark directory layout, and tuned log levels so your shell isn't a wall of text. We can do that by running it here. Okay. So let's conclude this video here. And if you enjoyed this video, don't forget to like and comment, and do practice those commands that I have shown here. And we'll see you in the next video. Have a great day. Peace out and love you all.